Okay, walk. Today we're going to journal page 15, inverse of exponential and log functions. Example 1. Find the inverse function f inverse of x for f of x, when f of x equals 2 to the x plus 3 minus 5. Remember, step 1 is just to look at the function, identify, well, in this case, it's exponential. Step 2 is change f of x to y. So y equals 2 to the x plus 3 minus 5. And then the next step, step 3, is to switch x and y. So x equals 2 to the y plus 3 minus 5. And then step 4, solve for y. So we're going to start by adding 5 to both sides. So then that's x plus 5 equals 2 to the y plus 3. Now, the next step is what we're going to do. The opposite of exponential is log. So you see the base 2. What we're going to do is if you do log base 2 of 2 to the y, okay, plus 3 in this case, this basically negates each other, so those go away and you're left with y plus 3. Okay, so that's why we need to do that to here. But remember, because of the equation, what you do to the left side or the right side, you have to do the left side as well. So we're going to take log base 2 of both sides. Okay, so we're going to do log base 2 of x plus 5. I'm going to put this in parentheses, equals log base 2 of 2 to the y plus 3. Now remember, that goes away now, and so you're left with y plus 3. So we have log base 2 of x plus 5 equals y plus 3. Let me just check my phone, make sure that's not important. It might be, but I think it can wait, so I'm going to go ahead and finish this lesson with you, okay? So we're going to subtract 3 from both sides, and it appears we've run out of room, so we'll come back up here, and we have y equals log base 2 of x plus 5 minus 3, which we know is the equivalent to the f inverse of x. Okay, so go ahead and finish the first part of example 1. All right, now let's take a look at example 2. We're going to graph. So we're going to start by graphing f of x equals 2 to the x plus 3 minus 5. Okay, now I've mentioned it, but I'm going to actually show you how to graph using Desmos in this case. Okay, so we're still going to need our table to fill out, but we're going to go to Desmos. So let me click over to Desmos here. All right, so I'm going to come over here, and before I do that, I'm going to go over to this help key, and I'm going to press this, where's it at? Keyboard shortcuts. Why I'm going to do that is to show you where to get the exponent and log. So give me a second. Let me find. There's I found it earlier. So first off, we're going to come back to this, but you see where it says A to the B? You're going to press the shift and then this lower key button here. So your step, and that will do a lowercase. We'll come back to that. That's going to be important. But right now we need it for exponential. I don't think it shows the exponential, but that's just shift the triangle key. But just know that these shortcuts help on some of the buttons that you might need to press, okay? All right, so I'm going to come over here. F of x equals, and then it's 2, shift number 6, and then parentheses. You have to put this in parentheses, x plus 3. Click to the right once, twice, minus 5. Press enter, and let me hide that. And then I'm going to move the graph over, and so we're going to use this to find our points, okay? So here it looks like the first best point is right here, so that looks like that's -1, 2, -3, -4. So our first point is -3, -4. Right? And then our next point is, it looks like -2, -3. Okay, and then this point looks good. -1, -1. And then come up here, 0, 1, 2, 3. I think that's probably, yep, that's probably our best point there. Now you'll notice that it goes infinitely in the negative direction, but it never touches the -5. And I'll prove that to you if I zoom in, zoom in, zoom in. You can see here, when you zoom in, it's really, really close to that line, but it never touches, okay? So keep that in mind. Okay, so now let me switch over to this screen. So the graph, here are the points that we got from the table, okay? So let's go ahead and graph those, okay? So -3, -4. So -1, 2, 3, 1, 2, 3, -1, 2, 3, 4, -2, -3, -1, -1, and 0, 1, 2, 3. Okay. Now you'll notice that here is our asymptote right here. And let's draw a dashed line so we know that we don't cross here. Okay. So our curve, we know from the computer, it goes like this, goes to these points, back up, and like that. Okay. All right, so there's our f of x. Now for the inverse, real simple, we're just going to switch the x and y. All right, so just switch the values. -4, -3, -1, 3, -3, -2, -1, 0. And let's graph those points. Okay. So let's see. First point, -4, -3. So -1, 2, 3, 4, -1, 2, 3. Okay. And then -2. I'm sorry, -3, -2. I looked up there for a second, but I need to be looking here. -1, -1. And then let's see, 3, 0. So 1, 2, 3. Okay. Now you notice the asymptote here was y equals -5. Okay. So when you do the inverse, that switches. So now we have an inverse at x equals -5. So -1, 2, 3, 4, 5. So let's go ahead and draw our asymptote. Okay, so we know that our curve is going to, just like this one started by the asymptote, this one's going to start by the asymptote, never touches, and goes up through there. And you can see that they reflect over the y equals x, or f of x equals x line, and so they're inverses. Okay. Oh, almost forgot. All right, so go ahead and finish up that. And I'm going to go ahead and tape this to here. If I can find my tape. Ah, tape's right here. Yay. Okay. All right, let's go ahead and move on to the next page. All right, inverse of exponential log functions shown on page 15. Find the inverse function f inverse of x for f of x. F of x equals log base 2 of x minus 3 plus 4. Okay, so step 1, we just identify, well, this is a log with a base of 2. Step 2, change f of x to y. So y equals log base 2 of x minus 3 plus 4. Okay. Next step is switch x and y. So x equals log base 2 of y minus 3 plus 4. Okay. Now we're going to subtract 4 from both sides because our last step is to solve for y. So then you have x minus 4 equals log base 2 of y minus 3. Now, in the previous example, what we did is do log of both sides. But here, in this case, we're going to do log 2 raised to the log base 2 of y minus 3. And what happens is that when you raise a log base 2 by 2, that goes away and you're left with y minus 3. Okay? But remember, what we do to one side, we have to do to the other. So we're going to raise this base of 2 and then this base of 2. Okay? So then this goes away. We're left with 2 raised to x minus 4 equals y minus 3. We're going to add 3 to both sides. Ran out of space, so y equals 2 to the x minus 4 plus 3, which we know is equal to f inverse of x. All right. Now to graph this, we're going to again use the Desmos feature of the calculator. Okay, so let me exit out of that. So then f of x equals, now you can actually get, let me hide that, and I don't need this writing feature. All right, you can actually get the log key by pressing function and go log right here. Now I'm going to click to the left because I need the base. And so this is where I'm going to press shift and it's the key to the left of the equal sign. Okay, it's between the 0 and the equal sign. Okay, notice now I have base. That's why I showed you earlier in the video that we were going to use that. Okay, and that was found, let me just review, help, keyboard shortcuts, and that was this right here. That's where I got the lower. Okay. All right. And then that's log base of x minus 3. Click to the right, plus 4. All right, and move the graph over so we can see it. So we're going to find some points. Okay, it looks like, now that looks like a point, but let's look at something. 1, 2, 3. I'm going to zoom in there really close. So you see it gets really close to 3, but it never touches. Okay, let me zoom back out. So we know we have an asymptote at x equals 3. But we have points, it looks like at 2, 1. That's our first point, 2, 1. And then 3, nope. 4, 5, nope. 6, 8. Looks like, oh no, that's getting way far out than we want to graph on the paper. So we know 2, 1 is a point. And then, yeah, so those are getting pretty far out. So we're just going to have to, unfortunately, just use the 2, 1, but know that we have an asymptote. Wait a second, I'm sorry. So let me take a step back. I was zoomed out way too much and I looked at points wrong. So 2, 1's not a point. So be careful with that because that's a mistake I just made. Is make sure you zoom back in after you find the asymptote. Zoom back in so you can see the table correctly. So here now we have points. 4 is a point. And then 5, 0. And then it looks like 6, 7. Let's say that's correct. 7, 6. Okay, and then guess we can use 11, 7. Okay, all right, so now we have our points. Let's go back to the graph. And remember, when we have an asymptote at x equals 3, so let's do that first, okay? So x equals 3, we have an asymptote. Okay, so now let's graph our points. So 4, 4. So 1, 2, 3, 4, 1, 2, 3, 4. Okay, and then 5, 0. And double check what I'm looking at in the graph. I think that 5, 0 is wrong because 5, 0 is right there. What am I doing? That is 5, 5. So again, I'm making mistakes, but I'm keeping them in the video so you can see that even as I'm doing this, I make mistakes. But it's important that if something looks wrong or you're concerned, it's always important you go back to your graph and you can fix those mistakes. Okay. All right. So let me go back here. So 4, 4, 5, 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then 7, 6. So 6, 7. 1, 2, 3, 4, 5, 6. Okay. And then 11, 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7. Okay, so there's our function. Remember, this line goes very close to 3, but never touches. Okay? All right? And so those are the values we used. Okay? Now for the inverse, real simple. Okay? We just switch the x and y's. Or x and f of x's. Okay? So then that's 4, 5, 6, 7. And then that's 4, 5, 7, 11. Okay, so let's graph those points. Okay, but before we do that, remember, inverse is the asymptote of this was x equals 3. The inverse will be the opposite at y equals 3. So let's go ahead and graph our asymptote first. So then that's 1, 2, 3. So we have an asymptote at y equals 3. Whenever you're doing logs and exponentials, it's important that you graph your asymptotes because that tells you where the curve is not going to touch or cross. Okay, so y equals 3 is your asymptote. Okay, so now let's graph the points. So 4, 4. So 1, 2, 3, 4, 4. Okay, 5, 5. 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And 7, 11. So 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And remember, we know that it's going to fall along here, the asymptote, never touch, go up through the points like so. And you can see here that it reflects across the f of x equals x line. So the inverses. Okay, so go ahead and finish that up. And yep, so today you want to make sure that you complete your my.hrw.com assignment. And also, note for today is, the days that you do HR8 or my.hrw.com assignments, you don't have to do the Khan Academy SAT prep. Okay, so go ahead and get your notes completed, get the assignment completed, and have a wonderful Wildcat day.